Chapter 4.5, Numerical Integration. The Trapezoid Rule, Day 2, Graphically. Yesterday we looked at areas underneath the curve, estimating them using the trapezoid rule. And yesterday we had a formula that for the curve we're finding the area underneath. Today we're just going to have the graph. All right? So it's going to be the same thing. We're going to have a graph. We're going to find the area underneath it using trapezoids. And we're going to need to use trapezoids because we can't calculate the exact area, so use the trapezoids to estimate it. Yesterday we saw there were some functions you can't do the antiderivative of, and that's why the trapezoid rule is necessary. Today we don't have the actual function, so that's why the trapezoid rule is necessary today. All right? So let's start with this graph. We're going to estimate the area under this using the trapezoid rule with n equals 4. That's where 4 is the number of trapezoids. So we're going to go from 0 to 8. Let's call it f. Doing 4 trapezoids. All right? So we're going to have a trapezoid here, a trapezoid there, a trapezoid there, which curiously ends up being a rectangle, and a trapezoid there. Now, because our trapezoids all have the same width, we can just do b minus a over 2n times f of the first one plus twice f of the second one, or second height, and so on all the way till the end, where we do just once times the first one. So b minus a is 8 minus 0. We're using 4 trapezoids. 2 times 4 is 8. F of the first one, f of 0 is 0. Twice f of the second one, so that'll be 3. Twice the third height, so that'd be 9. Plus twice the fourth height, that'll be 9 again. And then plus the last height, and that'll be 0. All right, so as we finish this, it'll be 6 plus 18 twice. So the area underneath this curve is approximately 42. Let's try it here, right? This one, they kind of give us less guidance. They're not telling us how many trapezoids to rule. They're not telling us a whole lot of information, which actually kind of makes it easier. Because we can choose how many trapezoids we need to use. We can even make them different widths. All right? I'm going to build this trapezoid here because that seems like a relative straight shot. Keep this one here. That seems a relative straight shot. And here, make that one a little bit wider. So you can see here, I'm not using all my trapezoids to be the same width, which allows me to, this one right here, a little bit wider, so I can make fewer trapezoids. All right? So here, this trapezoid, the base is 20, so half of 20, times the sum of the heights, so that looks like 75 and 85. So that's my first trapezoid. My second trapezoid, again, my base is 20. And we'll go sum of the heights, so that'll be 85 again. And you can see it's used twice. And this one looks like about 70. And I'll use my third trapezoid. This one, the base is 30. And my height is 70 plus, it looks like 72. And I'll do my fourth trapezoid, which is 20 again, times the sum of the base, which is 72. And this one looks to be about 60. Plus my last trapezoid, which is a triangle, which has a base of 30. Times, in this case, just the height would be 60. And so there I got all my trapezoids, and I can calculate an area to go with that. So as I do this, we'll have 1/2 of 20 is 10 times the sum of the heights, 75 plus 85, plus 1/2 of 20 is 10 times the sum of the heights, 85 plus 70, plus 1/2 of 30 is 15 times the sum of the heights, which is 142, plus 1/2 of 20 is 10 times the sum of the heights, which is 132, plus 1/2 of 30 is 15 times 60, and then we got our estimate, 7,500. Okay? So the area under this, between this road and this stream and this picture, is about 7,500. They don't got units. I'm going to estimate square feet. All right? Let's look at an application problem. Here we have Lake O'Galley in O'Galley, Wisconsin. Let's estimate the surface area of this lake. First off, we got our scale down here. To help us find the area. So we need our scale. You can see as I put a ruler up there, 2 centimeters on my ruler equals about 2,000 feet. So we're going to use that as we do our ruler across there. First off, I need to divide the lake into trapezoids. And I'll do that. Let's go vertically here. If we did it horizontally, we wouldn't get very many trapezoids. It'd be less accurate. So we want to do it vertically because we can draw it more accurately. And I say vertically, meaning north and south. You could obviously, if you wanted to, turn your paper and do it horizontally. All right? So we got Lake O'Galley divided into trapezoids. And now I need to, and you can see each trapezoid is 1 centimeter, which end up being 1,000 feet. I need to now find the heights of each of those trapezoids, or the way I have it, the base. All right? The first trapezoid, and be very careful here how you look at your trapezoids. The first trapezoid we got is 400 feet, or 0.4 centimeters. Right? The next one, you can see there's a little gap here. So I'll find it, find the base, and I'll subtract that gap out. It ends up being about 1,100 when you subtract that gap out. It's not a very big gap. Right? And so we'll get all of our heights. Here we got 1,800. Here we got 1,600, 1,900. 1,400, 1,000, 1 centimeter, 1,800, 1,600, and again, these are approximates, 1,500, and this last one down here is 1,000. I made that the last one because this last trapezoid doesn't have a full base to it. So I'm going to take this last trapezoid and do it separately. That looks like it's a 500-foot base. And our height of this trapezoid looks to be about 200 feet. So 1,100 and 200. Now as we plug that in, we get this as our big equation. We got 1/2 times our original base, 1,000 feet, each of our individual heights down to the last trapezoid, plus that little extra trapezoid that's not the same size. All right? And so then we'll calculate that out, and we can see that Lake O'Galley is 18,825,000 square feet, which I don't know, seems huge, 18 million. But if you know anything about O'Galley, that doesn't sound right. Let's divide by 5,280 because it's square miles or square feet. We need to divide by 5,280 squared, and we get 0.675 square miles, which seems like a lot better estimate. All right? So in review, trapezoids. The trapezoid rule. We're taking a trapezoid and using it to estimate the area underneath a curve, 1/2 the base times the sum of the heights. If we're doing it with multiple trapezoids that are all the same height or all the same base, we can use this formula. Otherwise, we add the trapezoids up separately.